Hello everybody, welcome to this new video. Today we will talk about irrigation and water management, mostly about water retention techniques in the field and uh, at crop level. So why is this an important issue? So at small scale level it is quite logical for the farmers. They directly see the problem they can have with water management and water scarcity. But it's also good to have an idea of the global picture. So on the global level, agriculture today consumes 70% of the world fresh water with an efficiency of only 50%, so all the half of it is actually lost, and the need is growing. According to experts, the need for water will grow by 50% to meet the needs of the growing population by 2050, and because of this, there's an uncertain future because by 2080, 30 to 60 million hectares could become unfit for production. So today we will have three main parts on this video. First, we will talk about irrigation in general. What are the possible irrigation system? What are the advantages and disadvantages, and what irrigation practice can we do to optimize these systems? Then we will talk about water retention techniques. So firstly at crop level, so how to maintain the water under the crop, and then at plot level, so how to maintain the water in the plots. So firstly, we will, as I said, talk about irrigation and the different irrigation systems. So firstly, why implement measures to optimize irrigation? So as a first reason, to save money. To irrigate costs money, it needs time, it needs work, it needs gasoline if you use a pump. Secondly, sometimes it's necessary to optimize irrigation because your water resources are scarce, mostly in the dry season, but you also can be doing dry episodes in the rainy season. And thirdly, to preserve resource in the environment, a lot of techniques to optimize water use is also beneficial for other aspects of the environment, for instance, biodiversity. So what are the factors influencing water loss? Just as a reminder, you have two main channels of water loss in a plot. Evapotranspiration, so the water who is going back to the atmosphere, mostly influenced by temperature, by the sun and by wind. And runoff, the water that is circulating and getting out of your plot, usually influenced by the slope, soil quality, and the possible barriers that you would have to prevent water from running on your fields. What can we do to optimize water use? Firstly, so we can act on these two factors that we just saw. So we can limit evapotranspiration, firstly by um, applying good irrigation practices. So we'll talk about it just afterwards. By having an efficient irrigation system that does not lose a lot of water. As we just saw at the beginning, 50% of the water used in irrigation by agriculture is lost worldwide. And of course, we can limit evapotranspiration by having soil cover and then protecting the water in the soil from the sun and from the wind. And then we can act on the second factor to limit runoff, to limit the water flowing out of your fields, and that we can, it is highly related to erosion control because you can, if you limit erosion, you also limit the water that you lose from your field. So, as I said, we'll talk about a few good irrigation practice. So what can you do to optimize your irrigation and your water management? So first of all, you can apply water retention measures. So as I said, we'll talk more specifically about it on the second and third part of this video. But you could plant hedges and belts. You can do contour landscaping. You can plant stone barriers. You can plant dig size and half moon, so we get to these different measures later. You can cover the soil by mulching, of course. You can also do crop association to have a better cover of your soil and then limit evapotranspiration and water runoff. You can also plant your rows more closely for the same reason. The next good irrigation practice is to try to support, to activate the root growth of your crops to make the crops less depending uh, on your water inputs. So that means you could limit irrigation at the beginning to promote root growth. That means when you plant a crop, so that here we're mostly talking about vegetable that you will transplant from a seedling into the soil. When you do this, you have to water it a lot so that it doesn't die at the moment of transplanting. But then you can, after the first big irrigation, you could leave it without water for a few days, depending on temperature. You should not kill it. And if you do this, you will stimulate root growth because the plant will have to look for more water, and then you will generally need less water, and you will waste less water when you irrigate. So after this first installation period, you can start the normal irrigation plan. And this is particularly important with drip irrigation, where the water is coming really close to the crop. So if you don't do this, you really have a shallow root system, which then is really dependent on your on your irrigation system, and also who is not able to get a lot of nutrients. Next practice, do not wet the aerial parts. So firstly, because if you wet your plants, you favor the spreading of fungal disease. Also, if you do this during the day, you could cause a thermal shock that could kill your plants. But of course, it is not possible to avoid wetting the aerial parts of plant if you have a sprinkler irrigation. And then you should irrigate according to plant need and to the season. If you water too much, you will waste water resource. Maybe you don't care if you have enough water and you have a system like a solar pump and it doesn't cost you anything to water too much. But if you have a water source which is not that big, if you are irrigating with mortar pump and it costs you a lot, it is really advisable to estimate and calculate accurately how much water your plants need and elaborate a good irrigation plan to limit the amount you need, and also to be sure not to underwater, because then you could have bad yield and even death of your plants. And then lastly, last but not least, quite logical, don't irrigate during the day, because it could cause a heat shock, because you get the temperature of the plant really lower by getting it by bringing in cold water to the soil. And also it is not efficient because the water will directly evaporate and the plant will not be able to get it. So to summarize the good irrigation practice, apply water retention measures. So we will talk about it just afterwards. Always cover the soil as much as you can. Limit irrigation at beginning at planting to stimulate root growth. Do not wet aerial parts. Irrigate according to the needs of the crop, and irrigate in the morning and evening, not during the day. Now we'll just make a quick overview of the different irrigation system and what are the advantages and disadvantages. First of all, you have the manual irrigation. So you would just irrigate by hand with a water can. You can make improved manual irrigation by having a pump, pumping from a water source like a river or a well, and then filling some reservoir which you could then just fill your water can in it. This is advantageous because you have almost no investment. So if you have an improved system, there's an investment in the pump, but still you don't need um, more irrigation system than just the pump and maybe a reservoir. It is efficient. You don't lose much water by doing so. You do not wet the plant, so you don't have this risk of fungal disease. And it is a really precise irrigation. Disadvantage is it's labor intense, so you need a lot of people to water your fields like this. And sometimes you don't want water enough because people get tired and don't give enough water, and also because you don't really control precisely how much water you give, and it's not evenly distributed on your fields. Then you have the sprinkler system. So it's a pressurized system with that is drawing water in the air, which is then coming down, as you can see on this scheme. It is an efficient system. It's ideal for sandy soil because you wet everywhere, so you don't have this effect of drip irrigation that do not do that cannot that will just water at the point where the drip is if you have a sandy soil. It's suitable for sloping or an uneven fields. It can be used to reduce the temperature of the leaf, but always be cautious with heat shock. And it's not costly, as for an irrigation system, it's quite cheap, but it's still an investment. As disadvantages, you need a strong pressure, so you need a good pump or just a few sprinklers. You have a risk of fungal disease and thermal shock because you moist your plants. You have an uneven distribution of water, and you have a lot of weeds because you water everywhere. And you can have a lot of water loss in uneven distribution, mostly if there is wind. Then you have the gravity irrigation system. So you would just dig some channels to get the water in the field and then bring it to the crops. It's advantageous because it doesn't need any energy. You can just use the gravity. You don't need a lot of equipment. You don't need it does not need a lot of workload during irrigation, and you can irrigate the entire root zone. But it's really not efficiency. The water goes in the soil and evaporate everywhere on the way, so you lose more than half of the water if you use such a system. You have a risk of erosion because you actually have artificial runoff on your field. You can have too much water that can be damages to the soil, but also to the crops. And it's really intensive work to establish it at the beginning. And then you have drip irrigation, which is basically micro irrigation limited to the root zone. It can work at low pressure. So this is quite advantageous. It is really efficient with only 5 to 20% of water loss. You don't need a lot of people to work it. You can irrigate at any time. You don't have fungal disease because you don't wet the plant. You don't have much weed because you water only the root zone of the crop. And you have really a balanced irrigation because you bring small doses of water quite regularly. It's costly. It's also a lot of maintenance, so it can be a problem even after installation because you have, for example, a risk of clogging of dripper, especially if you have an unfilled water. And then you don't have a stimulation of root growth. That can be a problem, which is why it's really important with this system to make this stimulation at planting. And for this reason also it's not adequate for sandy soil, and it can be difficult to weed because you have the pipes on your way. Okay, so that was it for the different irrigation systems. So now we will talk about the different water retention technique that we can use. So as a reminder of the previous video, we will just talk a little bit of soil protection because it's of course really related to water retention. So what to summarize what you should do to protect the soil, you should protect it from the rain, and that means anti-erosion measure. And these anti-erosion measure often are also good for water retention because they limit either evapotranspiration or surface runoff. Protect the soil and its organic matter from air. That means limit soil turning. This is also an influence on water retention. If you have a soil that can absorb the water, you will lose less water, of course. And then add organic matter to compensate for soil losses, add manure, compost, mulch, or grow green manure. So this is also important if you have a really good fertile soil. With a lot of organic matter, it can hold a lot more water. The water holding capacity of organic matter is high, so especially in comparison to mineral horizon with really old mineral horizon of the tropics, the organic matter is essential to maintain water in your field. So yeah, as I said, anti-erosion measures are often water retention technique, and it goes both way because water retentions permit to maintain water in the plots and the crops, but also limit erosion by limiting water runoff. And this is why they are also anti-erosion measure. So now we look at the different practices that can be used to optimize water retention. Firstly, you can increase shading with, for example, agroforestry system, with hedges, with crop association. By that way, you limit evapotranspiration. You can use water retention techniques at crop level. That are techniques that we will look at that can help to maintain the water under your crops. And you can also use water retention techniques at plot level that will help you keep the water in your plots. And of course, just as I said before, the quality of your soil, if you have a soil rich in organic matter, you have a better water retention. So now we will first look at the different technique at plant level. So today we will talk about zye holes, half moon, about mulching, and we'll also talk about hugelbeds. So I'll explain what this is. So what a zye hole? It's a traditional West African technique, probably from Burkina Faso, which was developed by farmers in semi-arid and highly degraded lands. So in their language, zye means to hasten, to dig in the dry season the packed and crusted soil. So basically, the idea is to dig a hole about 30 centimeter diameter and about 20 centimeter deep. You dig this hole and then you fill it with manure, and then you will plant your crops in this hole. So you will plant a few crops, not just one maize, mostly two or maybe three, and then the manure will be concentrated in this small hole, but also the water, because around these holes you will build some little ridges so that all the water will be concentrated um, in the hole. And then often we also had the mulch on it in addition to that, limit evapotranspiration. So on the right you have a picture of women growing vegetable in zye holes in Guinea. So why is it interesting? It has a really high yield potential because you really have a concentration of manure and water just under the crop. It optimizes rainfall, so even if you don't have much rain, it will be concentrated in these holes. It facilitates watering in case you can irrigate, then you just have to bring the water in these holes and you don't lose it by watering around it. It saves manure or fertilizer because you have a localized fertilizer application. And it also helps to keep the manure where you want it, near to the plant, because it strongly limits erosion and surface runoff. On the long term, it increases soil fertility and controls water runoff and erosion. Of course, it also have some disadvantages, as it's mostly high work to install it. It's a really tiring job to do this. But if you do it at the beginning, that you can really get good results in, especially in dry areas. Then we have the half moon. They are similar to Xi but bigger. So it is the idea to dig a big half moon, like you can see on this picture, uh, similar to Xi, 20 centimeter deep, but a lot bigger, 2 meter wide, and then you will have 4 meter between the different half moons. And then you will plant all your crops inside this half moon. So it's the same principle as the Xi. The manure and the water will be concentrated on this part of the field, and the part in between will be used to gather the water inside the half moon. So how to make them? Deep, dig 20 centimeters deep, 2 meter in diameter, 4 meter between the different half moons, and you should plant them in staggered row to really optimize land use. You fill it with manure on the soil, you mix them, you sow the crops inside. You can sow the many crops like maize or sorghum inside it, and you can also plant, for example, bean or something and demanding under which you can additionally mulch it. And you should not cultivate the space between the half moons to optimize the effect of concentrating the water in these half moons. So what are the advantages? You get better yield because you have, so on the right you have a picture of a possible plot with this staggering row organization, and as you can see it is on a slope land, so it's really a technique particularly adapted to slope land to really limit surface runoff of a slope land. So to get back to the advantages, it's almost the same as I. You optimize rainfall, you facilitate watering, you save fertilization, you limit a loss of manure to runoff, and in the long term you increase soil fertility and you control erosion. Then you have mulching. I'm sure you know what it is. So to add straw or fresh vegetable material on the soil to protect it, to cover it. So you can use any vegetable waste, straw, branches, dried weeds, wood chips, coffee husk, just to cover the soil. It is good to maintain moisture in the soil. You limit evapotranspiration by blocking the sunlight. You protect the soil from the rain, so you reduce the impact of drops, so you limit runoff, and then you also nourish the soil, so you get a more fertile soil at the end. And also it is good for biodiversity because it gives a refuge for beneficial animal like spiders ants and other um, beneficial that we saw in the first video. Finally, we'll talk about Hügelbeets. I don't know if you already heard about them. They are called butte sandwich in French. They are called Hügelbeets in Austria, but it is a practice which is originating from Austria. So the idea is you can make it small or big, but the idea is to dig a furrow quite deep, up to 50 centimeter, and then you firstly fill it with decomposing wood, big branches if you have them, and then you get smaller branch on them, and then you get like straw or fresh material on it, and then you put the soil back on it, the earth back on it, and then a mulch on it. And that way you really have a self-fertilizing uh, yeah, bed that will over time everything will decompose and will furnish nutrients for the crops uh, uh, um, during a few years. So usually if you establish such a huckle bed, you can leave it like this without fertilization for 4 years at the minimum, and that way you will also not disturb the soil during this time, and you will be able to uh, limit erosion and concentrate the water on this huckle bed. So they are also useful for water retention because you really have a highly uh, you have a soil with a lot of organic matter that is able to maintain water. Okay, now we will look at a few possible water retention technique at plot level. So it's not the idea anymore to concentrate the water on your crops, but to maintain the water on your fields. So we will look at three different techniques: live hedges, belts, and stone barriers. So first, hedges are trees that you plant around plots or around farms. You can plant fruit trees, timber trees, or further shrubs that you can use to feed your animals, and you can plant them around your whole farm or around a few plots. So you have, for example, here a live hedge in Burkina Faso that protects our agroecological farm. You should plant the trees quite closely, maximum 50 centimeter, to have this effect of maintaining of creating a microclimate in the field, in the farm, and to prevent water runoff, to prevent wind erosion, and so on. So why you should do this? Because it prevents water runoff, it prevents erosion of wind and water. It creates a cool and humid microclimate inside the plot, so it reduces evapotranspiration in your plot. It can protect your crops from pests and disease, and it's really important for biodiversity, so it can be a refuge for beneficial insects and animals. And it is also productive, so you can have further free timber produced with these hedges. So a few example of species you can use. You can use moringa that you can on the left that you can plant quite closely. You could plant it like these Clericidia hedges that you see here. This is really close. It then can also make a fence to prevent animals from coming in. You can also use different fruit trees. For example, here the cashew. Which if you plant in the hedge can be pruned to uh, to pass in the hedge. So here you have a few examples of species you could use. There's a lot of legume trees you could use: acacia, calandra, glycyrrhizidia, leucaena, prosopis, sesbania. You can also plant some medicinal trees in the hedge that you can use, or biopesticide tree like neem that you could use to produce your biopesticide, or a medicinal tree like combretum, or other fodder tree but not legume like melina, jatropha, Caia senegalensis, or moringa, as I said before. Now we'll talk about belts. So belts is a bit the same principles as hedges, but not as big and not as intrusive. So it's more the idea to plant a smaller plant, maybe an annual, maybe a perennial, but a smaller crop that you can remove more easily, and that you can really plant over all your plots to really have a belting of all your plots, and in that way you will really keep water in your plot, keep water flow to your farms, limit erosion, and have this microclimate. So you have an example here of a possible farm. You will have a hedge around it, and then each of your plot you will be surrounded by grasses belt. So you could use, as I just said, grasses, and usually forage grasses like Bracharia, Penicetum, Panicum, Andropogon. They are interesting because they can be used as fodder, so you can cut and carry them, the harvest for your animals, and they are really effective in blocking water runoff. They're good refuge for insects, and they can be used to control pests in maize and other cereals, like we saw in the video about the push-pull system in the crop association. You could plant double rows of Penicetum or Bracharia at 40 centimeter to 40 centimeter between your plots. And you could also use them to fence animal pasture plots, and then the animals can just feed on the belts as well. You can also use pigeon pea, which is a legume, or the small leguminous shrub, which can also be used as fodder, which they are not as good to prevent runoff as grasses, uh, but they can be really good to make belts in grazing plots because they grow back quite quickly. You can also use fruit, for example, a pineapple is good to make such belts because it really prevents effectively runoff, but it's not as good for biodiversity or for insect refuge. But of course, then you get ananas, so it's interesting. You could plant different flowers to do these belts, so that way you won't have you will only have a partially blocking of the water runoff, but you will have a good attraction of insects, a high biodiversity, so it can be really interesting for pest control and also for pollination of your crop. So you have an example of such a flower belt in a wheat field in Europe. Finally, we'll talk about stone barriers. So they are shallow trenches filled with stones that you can, like belts and like hedges, plant around your plots, around your farm, and ideally follow or across your plots, ideally following the relief of the land. So, as I said, it's just a trench you dig that you fill with stones that you find usually locally, and you can surround your plot with it and then grow vegetable inside. So to make them, you dig 15 centimeter, you fill with the stones so that it gets 50 centimeter above the ground, and then you bring the soil back, usually downstream of the cordon, and then you can plant a belt or hedge or something else upstream of the cordon. Why you should do this? It is efficient at limiting erosion because it, as the belts and as the hedges, it limits runoff. So it's good to keep water inside the plots, and it's also a good refuge for animal and insects, beneficial to crop. So as you see, a lot of these measures that we take to to retain water in your crops, in your plant, are also good at preventing erosion, but are also good at increasing biodiversity and thus helping in the pest control on your farm. So that was it for the lecture about water management and water retention technique. Thank you, and see you next week.